Let's look at this problem. Inverse transform of 1 by s power 3 by 2. So first you write this as 1 by s power half plus 1. We write like this because inverse transform of 1 by s power n plus 1 is equal to t power n by gamma n plus 1, right? So in the present context, we will have t power half by half plus 1. So this will be nothing but square root of t by half gamma half. So you will have 2 into square root of t by pi. So this is a straightforward problem and the correct option is B. In this question, we will find inverse transform of 1 by square root of s plus 1. Please observe that the first shifting theorem is involved in this case. So first, what do? Identify the context. First shifting theorem. It says inverse transform of f of s plus a is e power minus at f of. So in this case, you will find that a is equal to 1. So you first start with inverse transform of 1 by square root of s. Okay, so that happens to be the basic function. So this is nothing but inverse transform of 1 by s to the power of half, right? Which you can write as inverse transform of 1 by s to the power of minus half plus 1. So what does this take us to? T to the power of minus half by gamma half, right? So this is 1 by square root of t and this is root pi. So this is 1 by square root of pi t, right? This is only the inverse transform of 1 by root s. This is where we apply the first shifting theorem. So what will be the answer be? The answer will be e power minus at. A is 1. So e power minus t, let us call this f of t into f of t. This is nothing but e power minus t by square root of pi t. So it is very simple. First, inverse transform of 1 by root s, get the output and then use the first shifting theorem, and the correct option is B. Friends, the next question that we have chosen is based on the second shifting theorem of inverse transforms. The problem is to find the inverse transform of e power minus s by square root of s. Well, let us write the second shifting theorem. So the context is second shifting theorem. It says inverse transform of e power minus as f of s is equal to f of t minus a into ut of a. And what is f of s? F of s is inverse transform of, or rather Laplace transform of f of t. So first here begin with 1 by root s. we've already seen this is 1 by square root of pi t. You call this f of t. So where are we now? We found out the f of t. Now the answer is here. This is the output. A for this problem is 1. So the answer will be f of t minus 1 into ut1, right? F of t minus a uta. A is 1. So what is f of t? It is 1 by square root of pi t. So how do you write this? u1 of t divided by square root of pi into t minus 1. So this will be the answer to this particular problem, and the correct option is A. The next problem that I have chosen is based on first shifting theorem. Of course, it's straightforward. First, modify the denominator, and then this s plus 1 should be recreated in the numerator. S plus 1 whole squared minus 1. So inverse transform of s square minus a square by s square plus a square whole squared. Now this appears like this except for s plus 1 in place of s. So there is a shifting theorem involved here, but that is a basic result you must know. And from your tables, this is t cos at. Now in this case, Laplace transform of s plus b whole squared minus a squared by s plus b whole squared plus a squared whole square in the denominator should correspond to e power minus bt cos at. So this is where the shifting theorem is involved. So if you connect those two things into this problem, you will find the answer will be e power minus t, because b is 1, into, there is a t here, please, you must not forget that. This t is to be carried, t cos t. So we can write it nicely as t e power minus t cos t. So this is a fairly straightforward problem, except for the completion of the squares in the denominator, and the correct option is C. Well friends, the next question I have chosen again to be on the first shifting property. It says find inverse transform of s by s minus 1 whole cube. Now always remember never to expand the denominator, right? Don't use any algebraic principles to expand the denominator. So what you do is observe s minus 1 in the denominator and recreate this s minus 1 on the numerator. So you subtract and add 1. So you treat this as one block and this as other one, and you break this into fractions. So you get 1 by s minus 1 whole squared plus 1 by s minus 1 whole cube, right? Now you must remember your principles, but I will write a formula for you. It says inverse transform of 1 by s minus a to the power of n plus 1 is equal to e power at into t to the power of n by n factorial. Of course, you must apply this 2 times because n plus 1 is 2 here, n plus 1 is 3 here. So you have to apply that 2 times, right? So we will write this as e power t into n plus 1 is 2. n is 1. So we'll get t by 1 factorial plus e power t into n plus 1 is 3 here. So n is equal to 2. T square by 2 factorial. So observe that e power t is occurring in both the cases because of the presence of s minus 1 in both the cases. So the correct option, if you simplify this, will be D.